This content is AI generated for informational purposes only and should not be directly used for clinical decision-making.
Hello and welcome back to the Neurosurgery Hub podcast. I'm Dr. Aris, a senior attending here, and it's a pleasure to be back in the studio discussing the latest literature that's shaping our surgical practice.
And I'm Dr. Alara, a research fellow. Today we're looking at a fascinating new study from the Journal of Advanced Research titled Proteomic Profiling in Cerebrospinal Fluid Reveal Biomarkers for Shunt Outcome in Idiopathic Normal Pressure Hydrocephalus. It's a multi-center collaboration involving the Department of Neurosurgery at Zhejiang University School of Medicine and the University of California, Irvine, among others.
This is a timely paper, Alara. For those listening who manage idiopathic normal pressure hydrocephalus, or iNPH, you know the clinical triad of gait disturbance, cognitive decline, and urinary incontinence. But the real headache for us isn't just the diagnosis, it's the prognosis. We're constantly asking, will this specific patient actually improve after a ventriculoperitoneal shunt?
Exactly. Currently, we rely heavily on the CSF tap test or external lumbar drainage to predict outcomes, but these have high false negative rates and carry their own risks. This study, led by authors like Yuki Ying, Hemmings Wu, and Junming Zhu, moves the needle towards precision medicine by looking at the molecular level, specifically the proteome of the CSF.
Let's dive into the methodology. Proteomic profiling sounds high-tech, but for the residents listening, how did they actually structure this?
The researchers performed a deep proteomic analysis of cerebrospinal fluid. They utilized sophisticated mass spectrometry techniques to identify proteins that were differentially expressed between patients who responded well to shunting and those who didn't. This wasn't just a small pilot. The study involved researchers from the Clinical Research Center for Neurological Diseases of Zhejiang Province and the Westlake Center for Intelligent Proteomics. They were looking for a molecular signature of shunt responsiveness.
And that's the holy grail, isn't it? We've all had that patient where the imaging shows Evans index greater than 0.3 and narrowed callosal angles. The tap test is equivocal, and we're sitting there in the clinic trying to decide if we should take them to the OR. If we have a CSF biomarker that says this patient has a 90% chance of gait improvement, that changes the conversation entirely.
Right. The study emphasizes that iNPH is likely a heterogeneous disease. By using proteomic profiling, they could categorize the fluid environment of the brain. The paper mentions identifying specific biomarkers that aren't just related to the presence of hydrocephalus, but specifically to the shunt outcome.
Did they specify which biological pathways these proteins are involved in? Often in iNPH, we talk about reduced clearance of metabolic waste or chronic ischemia.
The study highlights proteins associated with neurodegeneration and neuroinflammation. What's interesting is the collaboration with the State Key Laboratory of Transvascular Implantation Devices and the Department of Physiology and Biophysics at UC Irvine. They combined clinical neurosurgical data with high-throughput omics to ensure the biomarkers were robust. They aren't just looking at one protein like amyloid beta or tau, but a panel of biomarkers that reveal the physiological state of the brain.
It's worth noting for the residents that the paper lists several key institutions, the 4th Affiliated Hospital of Zhejiang and the affiliated Hangzhou First People's Hospital. This suggests the data comes from a diverse patient population, which is crucial for the external validity of biomarkers.
Definitely. And the study isn't just about discovery. They focused on revealing biomarkers that could potentially be used in a clinical lab setting. If we can take a small sample from the initial diagnostic lumbar puncture and run it through a proteomic screen, we might avoid putting shunts in patients who are actually suffering from a primary neurodegenerative process like Alzheimer's that won't respond to pressure changes.
That's a critical point. We often see a mixed picture in our older patients. The Hakim triad isn't exclusive to iNPH. If the proteomic profiling can distinguish between a patient with shunt-responsive iNPH and someone with a non-responsive phenocopy, we're reducing surgical morbidity significantly.
The paper also touches on the technical side, mentioning the use of intelligent proteomics from the Westlake Laboratory of Life Sciences and Biomedicine. This suggests they used machine learning or advanced bioinformatics to sift through the thousands of proteins found in CSF to find the ones that truly correlate with the postoperative clinical improvement.
For our practicing neurosurgeons, the takeaway here is that we are moving away from purely hydraulic models of iNPH. We used to think ventricles are big, pressure might be slightly high, let's drain it. Now we're understanding that the protein composition of the CSF tells a story about the brain's ability to recover.
And the authorship reflects that shift. We have neurosurgeons like Zhongming Zhang and Ligan Shi working alongside experts in pharmacology and biomedical engineering like Kevin Beer from UC Irvine. It's a multidisciplinary approach to a problem that has frustrated neurosurgeons since the 1960s.
Looking at the title again, Revealing Biomarkers for Shunt Outcome, did they mention any specific proteins that stood out?
While the deep technical list of proteins is extensive, the core finding is the identification of a proteomic signature that predicts success. They used clinical translational research to bridge the gap between the lab and the OR. The study suggests that these biomarkers are more than just diagnostic, they are prognostic tools.
So if I'm a resident in the clinic and I'm looking at a patient with a disproportionately enlarged subarachnoid space hydrocephalus, or DESH, on MRI, I should be thinking about how the molecular environment of that CSF is influencing the clinical phenotype.
Exactly. And as this research moves towards 2026, we might see these panels integrated into standard workups. The study by Ying and colleagues provides the groundwork for a liquid biopsy of sorts for the hydrocephalus patient.
It really underscores the importance of the collaboration between the clinical departments at Zhejiang University and the research centers for neurological diseases. Without that volume of patients and the high-end proteomic tech, you can't get this kind of resolution.
It's also interesting to see the involvement of the Department of Radiology. Understanding the proteomic profiling alongside the imaging markers we already use creates a much more powerful predictive model.
Well, this has been an illuminating look at the future of iNPH management. It's clear that the shunt or no shunt decision is becoming much more scientific and much less of a clinical gut feeling.
Absolutely. We want to thank the authors, Ying, Lin, Ga, and the whole team for this contribution to the Journal of Advanced Research. It definitely gives us a lot to think about for our next clinic day.
Indeed. To our listeners, stay tuned for more deep dives into the papers that are changing neurosurgery. I'm Dr. Aris.
And I'm Dr. Alara. We'll see you in the next episode of the Neurosurgery Hub podcast. Happy operating, everyone.